right. Welcome, everybody. Welcome to our final Atomic Red Team of the year. You've made it this far in the year. You don't have much longer to go. So hopefully everyone's holiday season is only going to get easier from here on out. So again, everyone welcome. I'm Matt Graber. I'm the Director of Threat Research at Red Canary, and I'm more than honored to have a former coworker and great friend of mine, Roberto Rodriguez, here with us from Microsoft to talk to us about Project Mordor, and specifically like touching upon like all of the hard work that goes into the creation of a data set. I just learned very recently that there's so much more that goes into the creation of a data set than I originally thought. And Roberto's got some incredible ideas about how he thinks about what data goes into a data set, the quality of the data, and there's so much methodology too, like as a researcher and detection engineer, that like had completely gone over my head until very recently. So I hope by the end of this, everyone watching this will have a newfound appreciation for all of the incredible work that goes into the project. So, Roberto?
Well, thank you very much, Matt, again for the introduction. Same here. I mean, we go, I would say, almost 2 years, like just knowing each other, and it's been great just to also learn from you. And I would say that a lot of the methodology that I have implemented into Mordor from the research perspective and trying to make sure that data is being mapped to adversary behavior, it goes also with your own experience as well, like sharing your knowledge and all the stuff. So thank you very much for sharing everything that you know with the community. Is definitely helping me a lot as a professional and also as a person as well. Everything that you share. So thank you, man. Okay, so let's just start with this presentation. So first, I believe that we have a Slack for the Atomic Red team. So any conversations or just additional questions, probably just drop them in there, and then I believe I can get to them at the end of this presentation. And as Matt says, so my name is Roberto Rodriguez. I work for the Microsoft Threat Intelligence Center R&D team. It's called the Mystic team. I love to share open source tools. So I remember in the first year in my career, I just felt that I was lost because I didn't know what resources I could use to start learning certain things. So there is when I started building my own stuff, and I figured that also helped me a lot, not just to learn, but at the same time to start meeting other people in the community and also start seeing how all those tools are helping others. So that definitely is a good feeling, because I believe that there's a lot of people out there that are probably just like me in my first year. And even right now, because every day there's always something new to learn. So I'm always trying to figure out like how to automate a lot of things. I'm also the founder of the Open Threat Research community. It's a community that I started just based on all the open source projects that I had put together, how we can start building a community around it. And then I got to know like a lot of amazing people also in the community that wanted to be part of it. So that was nice just to see others kind of like getting together as well and trying to share their knowledge through all these open source projects. Also, so we are transitioning right now from our Slack community to Discord, for a lot of reasons. But so that's pretty much where we're going in the future. So if you want to join this community, I would recommend to go to Discord. And then in our Slack community, we're going to slowly try to migrate all of them to the OTR, Discord channel. So in case you want to join us, that's the link, and slides are going to be shared at the end. So, the links are going to be there always. And something interesting, I guess, that probably not a lot of people know, I don't know, but so I'm from Peru. And that was actually in this slide, there was a message saying share something interesting about you. And I think that's I don't know if it's interesting, but it's always good to talk to people about food from different countries. And Peru is one of the places where the food to me is one of the best places to eat. So just sharing that out there. And that's my Twitter handle over there. So just in case you want to follow me as well, I share all my research through my Twitter through my Twitter account. So, feel free just to join me. I try to share as much as I can, from the stuff that I do there. So hopefully you can, keep up with a couple of things that I, share. Okay, so in this webinar presentation, we're gonna try to make it a little bit informal. There are not gonna be too many slides, but there's going to be a lot of conversation as well. And I'm going to go all over from what Mordor is, and also sharing a little bit of the steps that I believe are very important to start defining how the Mordor data set is going to be of quality. And we go through a couple of those research methodology steps, and then we're going to start talking about capturing a data set, like the whole process, but before we even get the data into a JSON file, and then we ship it to GitHub. And then at the end, if we have time, I have a new thing that I just put together yesterday, which is going to be interesting. And so I hope you guys like it. And this is, of course, if we have time. So hopefully we do. But anyways, Mordor, for those that don't know about it, is just a repository of data sets, sample data sets that were created after emulating adversaries. So there is always something out there to do research on. So when there is something in Twitter that I like, I just start my whole lab environment, start reading a little bit about the technology, and then I just create my data sets and I just share them with the community. This all thing started because my brother also wanted to start working with some data, and his background is more on the data science side. So myself, I was just building all these things and simulating a couple of things, but I couldn't share as much with him. And usually my own SIEMs were local in my computer, so there's no way to give him access to stuff like that. So it was easier just to get the data out of my computer and just send it a file, so that way he could also start helping himself with some new functions to start querying data and things like that. So that's kind of like the beginnings of Mordor. And then at the end, we figure, why not we just start sharing everything with the community? And since then, I believe that the community has benefit from it. And I hope that also you guys see the whole process today into how all these data sets are put together. It sounds easy, but there is a whole process behind it. And then at the end, this project is categorized by the MITRE ATT&CK framework, and I call the small data samples atomic samples. And of course, like more than one technique, they are the compound samples. So not just, for example, like one service execution, we might be also, collecting data from a whole, campaign. And of course, following standards from the community. I like to follow the attack evals, for example, and that's something that is going to give me a well-tested and also, in my opinion, robust kind of emulation plan that I could follow, so that the data set is not just me trying to just Google a couple of techniques and trying to put them together. So it's definitely a good reference to have. And the link at the bottom, so once again, all these projects are part of the OTRF community. So that's once again just a public organization out there from GitHub, and it's also community driven. So there is not companies behind it. It's just people from the community trying to have fun and just sharing as much as they want from from open source perspective. And this is the part that is going to start kind of like getting into the conversation a little bit. So to me, like when we start talking about data sets and trying to see what is the first thing that we do, there is something out there in Twitter, once again, like public intelligence, that I could just try to learn a little bit more and trying to share data. So the first things that, besides defining my research goal, because the research goal gets attached to just my curiosity most of the time, just trying to identify what it is that I want to start, doing research on. And I believe that the scope of my research, in my opinion, starts getting created just by asking all these questions, going through some steps. And sometimes my research goal changes a little bit, because sometimes I feel that my research goal, like, for example, let's detect lateral movement, is too broad. So as I start learning about these techniques, sometimes I try to adjust that scope, because once again, like if you just want to detect lateral movement, there is so many different ways that you could do it. So it's very important that you also try to get that scope a little bit more manageable, right, for yourself and also for your team. But the first thing that I do after that is I just want to understand the technology that is being leveraged through the adversary technique. And to me, like, this is exactly what I do. Now, of course, you don't have to follow this step by step. Like, for example, for me, first question, what's going on in here, right? What is this protocol right here? What is this tool? What is this specific service that that someone was talking about that could be used to, I don't know, perform an action over the network? So I start asking all these questions to myself, and I started just documenting my answers and trying to keep it organized. And in my opinion, the more you do it, I would say that the better the process is going to be, because you're going to identify sometimes like how you can structure your even documentation. For example, for me, I like to structure it first, like the basics. What does this actually even mean? Like, what is, for example, the service control manager? What is that, right? What is RPC? Like all those different questions go on the top, just basic definitions, and then I start breaking it down into the context around those specific concepts. Then my steps is I always read documentation. It's something that, to me, I have learned that that's something that I need to do first. Now, of course, a lot of people just dive directly into just trying to do some basic dynamic analysis or static analysis. To me, I usually would do that if I have no clue of like what's going on. I just want to start procmon or Wireshark or anything like that, or just pure event logs, and then I start getting an understanding of that. But if I have some basic knowledge around it, like for example, like if somebody says this service can be accessed through RPC, okay, great, let's go to the RPC documentation and start reading more about all the functions and methods that I could use through the RPC server. So that's kind of like the way how I start shaping my research. So once again, there is no right or wrong answer. It just depends how you feel about it. And once again, sometimes you just want to go deep into documentation. Sometimes you want to switch it.
Roberto, and to me, like, I'm getting the impression from you that you are the type that generally will never let perfect be the enemy of good, right? Because like,
Oh yeah.
if you can work with, like, start by defining, like, just having the basic definitions and understanding of the technology, understanding the documentation, how things are being used in the wild, well, then you've already, let's just say hypothetically, gotten to, like, say a 70% like coverage solution just based on that understanding.
Yep.
Because that's by and large going to be the majority understanding of everyone else as well who's put in any other level of effort. So yeah, that deeper dive, doing dynamic and static analysis, as sexy as that stuff is, and yeah, it's just like how exciting and mysterious it can be and fun it can be to like learn something new and novel and share it with the community. Like, yeah, I think we're on the same page here. Like, that's definitely going above and beyond and helps paint a better coverage picture, but it's not always necessary.
Yep. Yeah, no, definitely. And I think that, that's when somebody asks me sometimes, like, how do you, do this specific detection, like the specific logic, or, how do you get there, right? And it's not rocket science, right? It definitely is going to, take time. And as, the more you do it, the more you're going to start learning some techniques, to start, once again, like, for example, in this case, I kind of like learn now how to go, if I want to go deep into documentation or, deep into dynamic analysis, which is also the, easiest thing to do also, right? Just, run something and then just enable kind of like all the specific event logs in your computer, then you can get some idea about it. So it's nothing, I would say, as complex as it might be. But once again, that's just the first step, right? There are more steps to it, right? There is not just that one that you can just say, all right, I run it, get the data, and that's it, and then I share it. Right now, there is more to it, but at least like those basic steps allow me to understand or have at least some context around it. Right now, this step, I've seen it in a lot of other methodologies. For example, I've seen you, Matt, also like talking about it in presentations, and I've seen also other, people sharing their methodology, which is similar. But something that I added also based on my, I would say, like a little experience, like trying to draw some pictures of behavior to data. Like, to me, I learn, more by if I just visualize it rather than just trying to, to me, start reading my notes. Like, to me, I like to have it as a, picture. So to do that, you have to start modeling those components, right? The main components, in my opinion, that are going to make the technique to work, or the technology itself to work, somehow you need to model it, because in my opinion, the more or the deeper you go, for example, let's say like static analysis or dynamic analysis, the deeper you go and you're trying to get into the specific even piece of code that executes something, and you get there and then you don't, the way how I call it is that you don't zoom out of all that, then you might be missing some of the context around it that has nothing to do with, for example, just the the payload itself, but actually what are the unintended consequences of that payload once it executes. So, and that's something we're going to talk about in a little bit, but that has to do, for example, with authentication, right? When something executes something remotely, first question, how is that going to do it? What is the protocol being used? And is that going to be, for example, done in a specific authentication on the target computer? So that context, in my opinion, you start getting it once you start modeling the concepts around the specific thing that you're performing research on. So that step for me is very important. Once again, modeling the core components of the technique, and then you start identifying those data sources that you could use on each component. And this is, of course, very similar to doing some like threat modeling, for example, right? So that to me is very useful, and definitely has helped me a lot to start even enabling new data sources as well. And we're going to talk about this a little bit. But that's something that definitely I would something that I would add to the methodology to make sure that people have like a big picture of things. And once again, like zoom out from that complexity, and you can start getting some more context around it.
I'll completely echo that, and I think what you're describing is much of the art as much as the science that goes into the threat research methodology. And the way I see it is in how you were describing it is acknowledging when you should stop going deeper into a rabbit hole and recognize when you should pull yourself back out and contextualize everything that you've just learned.
Yes.
And like with some of the visualizations that you've done, like in your data models, has been awesome. Especially me, like as I'm trying to make sense of like how one data source is related to another one.
Yes, definitely. And when you start modeling, for example, the behavior of this specific technique, and then you map it to data, then you start asking those questions, right? Beyond just asking questions about the technology itself, then you start migrating into these questions about like, how do I join now these two events? And then you start getting into this beautiful but sometimes boring area of like data management a little bit, trying to understand the specific field names that you could use to start joining and stuff. And that, of course, is not that far away from also start identifying what field names for example, the adversary might have more control over, right? So, and to get to that point, you have to learn about data sources, and you have to learn about specific events, and you learn about every specific field name. For example, I loved the presentation that you did with Lee Christensen for the methodology for Sysmon, to to start understanding Sysmon, and also identify some like evasion techniques on Sysmon. That was great, because that was actually one of the first times that I would see like other researchers getting deep into these are the field names that might be control the most, and then start mapping that even to like Sysmon configurations. That was great, because you start understanding what's also something that you could evade directly just by looking at the specific data. So that was pretty cool. So I feel that that's something also that we need to do. And once again, that's when you start, once you start getting into, threat modeling a little bit, or just modeling the technique and the technology itself and mapping it to data, that's when you start getting into how can I just start joining all these data at the same time. So this example, we're just going to go over this basic, technique. This is something that has been, to me, a lot of people have blogged about it, have talked about it. And the reason why I use it is because it has a lot of interesting components that I believe we haven't even touched some of those that not recently, but I would say it's been already probably like a year or two that I started doing some research on trying to monitor access control to specific objects like services and files and registry keys. And I feel that that side of the, I would say, data collection strategy or data mapping has not been explored as much. And I believe that in my opinion, provides a new way to also start even collecting data when you start thinking about services on your endpoint, especially from a network connection perspective. Okay, so we're going to talk about that and just kind of following the methodology, and we're going to go over this very fast because we don't want to get trapped too much into like all these things that we can learn about it. But these are just notes. For example, these are my notes when I get to start learning about the service control manager, right? So first things that I want to know is, well, there is a registry that will map the services installed. So that means that if something gets installed, there's going to be a subkey that is going to be created, period. Then I start understanding that the SIEM actually is also an RPC server. So right away I started thinking, okay, so that means that there is going to be an RPC client. That means there's going to be a couple of methods that I can learn from. So I just started learning into how also a client can communicate with the RPC server when this is over the network. And then I start reading a little bit more, and then I find, oh, okay, well, there is this protocol, the SIEM remote protocol, which let me see if I have it in the next one. Yep. So this one over here is going to give me now information about that specific RPC server, the specific ID for the interface that I could use to communicate with it. Okay, so then I start thinking about RPC interfaces. If I did my homework, for example, if I started learning about data sets from network, I know that, for example, Zeek, data from Zeek is going to give me some information about this RPC data. So I start taking some notes. Once again, before I even start, doing any dynamic or static analysis or any simulations, I just want to learn from documentation. Then that takes me to the other topic, RPC. Like, what is that? And just to summarize this, very complex topic, if you start getting deeper into the internals of all this, it's just going to allow this client and server execution model where the client is going to ask for those resources from a service or functionality from a service remotely, and then the client can execute those functions that are exposed by the RPC server. And if the RPC server is on a remote computer, then I could start interacting with that server and executing those functions that get exposed by the server.
Hey,
right?
Roberto.
Yep.
So could I try to maybe offer a much more simple example of like the actual components at play here?
Yes.
So correct me if I'm wrong, is the RPC server component for service creation services.exe?
Yeah, so the services.exe is the binary that holds the code of the RPC server. So the services.exe is going to expose that functionality of the RPC server. Yep. So when somebody connects, for example, from a source computer to the target computer, and I want to interact with the SIEM service or the RPC server, I'm technically connecting with services.exe on the remote computer, because once again, it's the one that is going to host that code and it's going to expose that functionality to the client.
Yep. Now, speaking to the client, you're saying like this being RPC, it lends itself to being done remotely, but it can also be done locally, yes?
That's correct. Yes.
So like one example of an RPC client that would interact with the with services.exe, the server component would be like sc.exe, correct?
That's correct. Yes, because sc.exe holds the client code and starts using that in order to interact with the SIEM. Correct.
Cool.
Yep.
So last question. So you mentioned, I mean, many of us probably already understand, like there's registry modification that occurs when services are being created, modified, or deleted.
Correct.
Us potentially having a better understanding of the client and the server components, like who's doing what, is it safe to assume that it will be services.exe that's doing the registry modification, assuming that this RPC channel is being used to interact with the SIEM? Would that be accurate?
That's correct. Yes,
okay.
Yes, that's correct. And that's to me also what, in my opinion, creates and we're going to see that in a couple of slides in here. But just by understanding the concept that services.exe on the remote computer will be the one creating those registries, creates a little blind spot into the user that performed that action, because the services account is it's going to be looked as someone created it, for example, locally, right? Because the local service account is the one that is going to be, or the system account is going to be the one that will be handling that type of execution. So even though it's great to monitor for registry keys, you are a little blind into if that happened over the network or not, because services.exe locally is handling that communication from the client itself.
So thinking through the research process,
Yep.
knowledge of RPC and the interactions, as complex as this stuff can be,
Yep.
this is what can potentially supply that context as to who it was or what it was that initiated the request to create or modify a service.
The RPC aspect of this
Yeah.
will not provide much information if you looked at it only from the RPC server, which is being hosted and handled by services.exe. If you look at that interaction of services.exe with the registry, it's not going to be a clear indicator of who did it, because the context of modifying the registry is going to show the services.exe, and the user, of course, is not going to be a domain user or anything like that. So you lose some of that visibility just by the technology working as how it is supposed to work, right?
Mm-hmm.
So that's why, to me, I was thinking, how can we start trying to get a little bit more context that could give us the network context of someone doing it, right? So that's what we're going to be talking about in a little bit as well. But those are great questions, because that's exactly how I also start thinking about it. It's like, all right, so if the technology works the way it's supposed to work on the target computer, then I start identifying certain things that might not be as useful when I want to build a better detection. Why? Because based on my experience, for example, I remember that we both worked in once we worked together in a case, and you might remember that one, but there was a case where services were being created or installed like every day, right? There was somehow something that a Windows setting on those computers were just generating new services, installation of services every day, and then we had to do like a little kind of like like a statistics analysis, a statistical model to make sure that those being created are just the usual stuff and not like a potential potential anomaly of a service creation. So if you just focus on the registry keys, most of them are going to just blend in with an environment that just has a lot of services being installed like periodically. So to me, it's like, how can I add more context to this so that I could just take all these local service creations, executions, and start focusing on the network ones, because my research goal is detecting the ones over the network, right? So that's kind of like my So
and sorry, I like how specific and deliberate you were in stating what your goal is.
Yes, because I think that's and of course, in my opinion, we learn as we go, and we're going to be defining so many different goals that we're going to be having headaches in understanding. There is so much to cover, right? And then you start understanding, this goal is a little too broad, and I want to make sure that it has more details. And once again, it's going to facilitate your research as well, and it's not going to create so many rabbit holes, that you might probably just leave it there because it's just too complex, right? So, and once again, there is no right or wrong answer, right? Some people want to go very complex and figure out every single potential way that somebody can move laterally, for example, using services. But based on documentation also, I could say that they start mentioning two ways that we can interact with the RPC server. One of them is over SMB, and that one is going to be using the RPC sequence protocol, the NCA-CNMP, which is for name pipes. And that one is going to use the specific RPC endpoint called the pipe SVCCTL. So now I have some context just based on documentation. And then I know that there is also another way to do it, which is just direct RPC over TCP. Now, TCP is, of course, also wrapping the RPC and SMB, right? Because you have TCP, SMB, and then your RPC. But when it's RPC over TCP, then SMB just goes away and just direct RPC over TCP. Because to me, I was thinking about it when I was reading it, and then after doing some testing, I was like, wait, but TCP is also being used on the top of the RPC over SMB. But so it got a little confusing, because when I started reading about it, I was like, okay, so if it's RPC over SMB, then I should not see any TCP whatsoever. So those are just the questions that you start asking yourself, and that's how you start learning a couple of things that you might not be aware of. So I'm always honest, right? There's a lot of things that I don't know, and if I don't know, I just want to read more about it, and sometimes doing some testing or just asking other people. Like, Matt, I always ask you sometimes a couple of questions when I'm like, man, there's no way I can just figure this out right now. So I really appreciate your time all the time. I definitely reach out to you, man. So all right, so the next piece there now. So this is what we were talking about a little bit, Matt, and this is something that James Forshaw actually put together in a presentation where he started just kind of like summarizing some of those RPC endpoints and protocol sequences. And why this helped me? Because I want to know if there are other ways that, for example, there could be an interaction between my client and my server. And of course, the documentation is pointing to, once again, the name pipe implementation and TCP. And the one that you were talking about, Matt, local, is the ALPC. So that's also something just to keep in mind your documentation, right? When somebody asks you, can we look for RPC locally? Then you know that you have to be focusing on the protocol sequence all RPC. So that's, just to keep that in mind. And that's very helpful, because that could help me then later for another potential engagement or just a research goal, locally. Anyway, so just by reading, then I could start getting some understanding of my data. Now, this will not happen right away for a lot of people. Why? Because sometimes we just want to explore directly through simulation, and sometimes we might not have this type of context directly. But as you're building, once again, your process, and you do this more often, you will start identifying those events that were helpful for all the research processes that you did. So for me, if somebody talks about service creation, right away I start mapping 4697, 5145. I know that will give me some context around, for example, name pipes being used over the network, and then registry creations and setting the values. Now remember, this also cannot just show up just like that. But part of my process, for example, is also understanding the data that you have. And if you simply read the Sysmon documentation, there is only 24 events. Well, 24 events. The last event I did is 24, I believe. It doesn't mean that there are all 24, but you start learning so much about the context that these actual events can capture, that at least you can have an initial idea into what it is that you could start looking for. So once again, it's not rocket science. All I did is just go to documentation, see what it is that I could start, kind of at least mapping to my documentation. So I see this as when you are reading an Intel report and you're reading the whole report, and then you start saying, oh, this is, for example, lateral movement with WMI. Oh, this is execution with a specific, like living off the land, technique. So I see this the same way. My research, I start reading, and instead of mapping techniques from MITRE ATT&CK, I start mapping data sets to it. And once again, like I might be wrong after that, it makes sense. So I'm going to validate that hypothesis then later. And that's what the process is about too, is how you start validating your own assumptions, right? Because there's going to be a lot of assumptions. So throw them all out there at the beginning and start understanding how you can start validating some of them. All right, so one of the things that I do also is, to me, I like to start working with some basic proof of concepts so that I could start understanding technology a little bit better. And this is more on the dynamic analysis techniques. But sometimes I just pick a technique that I find in the wild on a specific procedure, and I just try to execute it and see what's going on, right? But I'm trying to always go now to start using some of the built-in functionality directly. And this project right here from James Forshaw, NT Object Manager, it's a great one. Now, I just updated these slides because he just updated his project like 10 hours ago. because I was like, reading a little bit, and then he tweeted something, and I was like, oh my god, like he just added the name pipe RPC transport to his project. So I was like, let me just take a look at it. And the reason how this was easier to figure it out is because when I worked with his tool, I made the assumption that his tool could actually use the RPC over SMB and using this specific RPC endpoint, which is going to be a name pipe. So I built all my code, and then when I tested it, it just didn't work because like it wasn't implemented in his code. But then he released it, and I was like, oh man, let me test this nodes from like last year. So let's just do a quick example in here, and this is gonna be very quick. So because I know we don't have much time in here, but what I have in here is how I can start interacting with the RPC server, for example, and start understanding this from at least from a network perspective, just to validate all those things. First thing that I do is I import his module, so NT Object Manager, and of course that needs to be installed from PS Gallery. The one that I'm about to show you right now is not available yet, and that's because he just released it, and it's in his GitHub repo, but it's not in PS Gallery. So what I did is I had to compile it, and then I had to get the DLLs from the NT Object Manager and also the NT Object API, I believe. Anyways, but those two DLLs, I had to put them in the module of NT Object Manager, and then I could work with his fresh new code. Anyways, the first thing that I do is I try to look for RPC servers across all my binaries, for example, in System32. So as you can see, I'm just going through every single binary, DLL or .exe, and I want to get all the RPC servers. And I also use the what's it called, debug help DLL in order to parse those binaries and be able to find those RPC servers. That takes, like, I would say probably a minute or two. So I already ran that for you. And then what I do is I start looking for that interface ID that I show you in the documentation, right? So that was very helpful to start understanding which DLL or which, for example, executable might be hosting the RPC server, right? Because in the documentation, it doesn't say services.exe, right? But just by doing this, for example, command in here, I could start looking for all these DLLs and executables, and I could see that the only one that returns is services.exe, because that's the only binary in the endpoint by default that contains the RPC server code that is going to be hosted and the one that is going to be used in order to provide functionality to a client, right? So that right away, it just validates the fact that services.exe is the one that contains the RPC server code, right? The other thing is now I want to start using the client, for example. And in order to do that, I just have to get the server and then use the get RPC client function. So that will give me the client, and then I can.
Sorry, dumb question. So the get RPC client commandlet, in effect, just has PowerShell.exe serve as the RPC client. In this case, the RPC client that's going to communicate with the SIEM server component, right?
Correct. Yep.
Okay,
correct.
Cool.
Yep. So once we do that, then we can start using it. But before we use this client, we need to connect to that client. It's going to connect to the RPC server. So pretty much we run the connect RPC client function, and then we point to the client, right? That's the client that we got from the server itself. And then we use the endpoint path, which is going to be the endpoint svcctl, sequence for name pipe. And then this is something that, for example, he added, which is the network address. So you can point to, I'm about to switch it. Yep. So you can point to, there it is. You can point to a remote computer, and that would connect to the RPC server, in this case, the SIEM directly. And so once I do that, then that's going to be, as you can see, so let me just start this pickup right here on the right. So the moment I run that, as you can see on the right, it just created this basic binding in here. And let me just,
I can't emphasize enough, by the way, just how beautifully abstracted all of these steps are with how James designed this module. It's just incredible. I encourage everyone to play around with NT Object Manager. Like,
Yeah.
I mean, it's like sysinternals on steroids. Like, there's so much functionality beyond sysinternals, and it's all scriptable too. So anyway, there's my plug for NT Object Manager. It's incredible.
And something that I just noticed too is that, for example, so in here when I did the whole like only connection, like the connection directly to the server. For example, I did this this morning, and it seems that did the authentication process as usual and connected. But I believe that since I already ran it, it's just kind of like caching that, so it directly went and created the file with this. So I could see the bind acknowledgement in here of the of the RPC connection. So after that, then I could start using, for example, the RPC methods that are RPC methods that are exposed by the RPC server. So the RPC client is just going to call for the method, and then it's not going to be executed locally. There's going to be a proxy going through the SMB transport, and then it's going to be executed on the target, right? So if we do that, then it's going to create a handle. As you can see on the right, it just got me the OpenSE manager request, and then it got me the handle. So I see how you can easily start crafting step by step into the whole connection. Every time someone just wants to query or create a service. And then after that, I could get that handle, and I could do a simple, for example, open service. And oh, this topic receive bad data. Why is it bad data? 1 second. Let's just troubleshoot this real quick. I don't know why I did that, but SIEM handle. Oh yeah, okay. So let's do this. Let me close. I think that I had the handle. I think it was open still, probably. Let's see. Let's check it out this one more time. I think that was yeah. That. Let's clean this real quick. If not, I have the pictures, so that definitely worked like before. Okay, so here now it gives me the challenge and everything with my user P. Gustavo. So before it didn't give me that, I think that it was just using a previous one, most likely. So now we just do this again. So let's just get a handle to the SIEM, and I could see that here. Let's just check it out real quick. Policy handle. Yep. Now let's just check this one out again. Let's see if, must be something must be weird. Okay, so we can, let me just check that out real quick because, and we don't have time, we can just change it, but let me just show you what, I must have changed the commands somehow, I guess, but just by copying and pasting from this to the other one. But as you can see, like this one creates the connection itself. The other one, you can see the open, at the bottom, you can see the OpenSE manager, for example, just by doing a simple command in there. I'm gonna see what I did different. I think that I didn't define that string as an integer, so that probably must be it. And then after that, I could use that handle, and I could use another RPC method like open service W, and then I could use the query services status, for example, just by doing all these steps. And then at the end, I could just get information from, let's say, Sysmon service. And as you can see, the number 4 in the structure of the status is in the second value. It's going to tell me just that the service was running. So just by doing these commands, we can craft the execution of just connecting to the SIEM and doing all this stuff. So that was very, very helpful, for me to also understand each step at a time and see what data gets generated. So let's go back now to our slides in here. So after doing this, then I could start understanding some of these interactions between the RPC client, the server, or just in general, the computer, the source computer and the target. And as you can see, I could start understanding a little bit better what's going on. And once again, I kind of like zoom out from going all the way to only RPC methods. And I want to understand what happens around it. So I could start just mapping a few specific events. Once again, as you can see, on the left, we can see that the process that does this is going to generate a connection to the RPC server. Then if it's done over SMB, there's going to be a name pipe being used. So I can map that directly to 5145. And then if a service is installed, either if it's done through RPC over SMB or RPC over TCP, 4697 is going to be created. Connections are going to also be created, but in this case, services.exe on the target, right? Because that's our RPC server and it's hosting that interaction. So it makes sense that the network communication is handled by services.exe. And as you can see, beyond that, Sysmon registry creations and sets, all that's going to be handled by services.exe. So even if you monitor for registry creations and modifications or anything like that, it's going to be done by services.exe if SIEM is used, right? So if I go to the environment that had services being created from time to time or almost every other day, then it might just blend in, right? Because services.exe is handling that, and I don't have a way to point services.exe context to a remote connection, right? So that was kind of what I was thinking. I was like, it makes sense to look for 4697 or 5145, but then the questions start, all these questions. If an adversary, for example, modifies a service, then 4697 is not going to show up, right? Because the service is not installed anymore. And then if he uses RPC over TCP, then 5145 on the top right is not going to show up. And the only context that I start getting is just from the registry perspective. So the adversary, in my opinion, once it starts switching, to these type of decisions, you start getting rid of the network context. Like 5145, that could be that has information that could tell me this happened over the network, and then 4697, I can join that with an authentication event, and it would tell me that this was done through a logon context that was a network connection. But if it uses RPC over TCP, and then it just modifies a service, then I just lose all that network context. So from that perspective, right? Of course, there is other context that we could use, but at least this model allows me to understand some of those potential evasion techniques. Just without even asking those questions, I can start thinking, oh, if they do this and that, then my visibility starts going a little bit, to the point where I might just be dealing with local registry modifications and creations, which might not help me as much, right? Now, what we usually do is we look for those registry keys under the, the SIEM database that, that look suspicious, right? That's kind of where we go to right away. We say, okay, you know what? Let's look for any modification under services, and then we see what looks suspicious. But we know that there is one the adversary has control over, right? Because they have control over the name, over the values. So you're just pretty much dealing with whatever the adversary is providing to you. But 4697 and 5145 to me are more about context, right? A name pipe being used, SVCCTL, is not going to be that easy to change if you're using RPC over SMB. So there's when I start identifying those main components that will make this technique to work for a specific protocol. But then I start asking myself, right? So if I just focus deeply into RPC servers and clients and just modification of a registry, I lose context around, for example, there was a handle, right? In that case, there was a handle requested. So at the end, there is also authentication going on. So I could also use that. But the handle itself is very interesting, because either if you do it through RPC, RPC over TCP or RPC over SMB, or even if you modify it, the service itself, you're touching the SIEM service, the SE manager service, and the handle is the one that is going to provide that information to you that somebody is it's requesting a handle. And then you can map that into another event that will give you some of that network context, like, for example, 4624, 4624 security event. So that to me is when I start kind of like figuring out, you know what, it makes sense to start monitoring for this. But the reality is that the handle of the SIEM is not monitored by itself, by default. The specific, we can just jump to the other stuff in here. Here's when we start getting into, for example, SACLs, understanding how the authorization access control actually works, where there is an object that has a security descriptor, that has access control lists, and one of them is of type of system access control list. That's the one that would allow us to define what type of access attempts we can monitor, right? Just directly. That's pretty much what a SACL is about. DACL is to define who can access it and what type of access they can have, right? But the SACL itself is just give me all the data regarding this specific access right that somebody attempted, to request for what's it called, for my specific object. So in this case, my object can just be a service, or could be a registry key, or a file, right, or a process. So I started kind of like going deeper into that, and then I identified that in my model now we have the event 4656, which is going to be the one around the handle. And that's when I started understanding, okay, so if I just run this technique with a couple of variations, and I just enable all the telemetry, right, using audit poll, enable everything, and collect everything, I miss that 4656 because that needs an additional configuration, right? Because you need to add what is called an access control entry in the SACL of the object itself. So you start getting into those concepts that to me, that's what we start focusing a lot when we start building or just creating Mordor data sets. That additional research of just understanding what it is in my model in here that I was not covering, and how I was able to identify what it is that I could do in order to enable that, because by default it's not enabled. So that at the end is going.
Roberto.
Yep.
Like what you just covered right there on that last slide. Like go back one. Like this, when you were explaining this to me, that's when the light went off in my head of like, oh, like I now understand why I can have such a deep appreciation of everything that goes into the creation of a Mordor data set. Mm-hmm. Everything that Roberto just said here, all of the research that he just captured in this relatively complex but extremely succinct to me slide right here. Presumably, this is everything that you would attempt to capture in a Mordor data set for, exactly, in this case, remote service creation, yes?
Exactly. Yes, exactly. This is what I would cover. Of course, there is more that we can do in here, right? From a data perspective, because we haven't even talked about ETW, right? But at least from something practical that I could tell someone right away, use this audit poll command, and you can enable the for example, collection of those events like 4656. 4656 is part of the audit category object access, and the subcategory, I believe if I go to the next one, that would tell me. Yes, it's called audit other object access events. So this is very interesting because object access has a lot of things like registry, file, has like a lot of like audit detail file share. So monitoring a service was actually interesting to identify the specific subcategory, because that's not documented. No one tells you enable audit other object access events if you want to monitor SACLs on the services. So that was by just testing and trying to see what was going on. So you see how we went directly from just a few events to a few more, and then we just added the 4656. That's to me when I start understanding what events might stand through a in my opinion, robust detection. So even though we identify like 4697, 5145, and all those at the beginning, and those look strong, when you start looking at some of those variations, you identify that the last one that we identify, just by trying to figure out what were the components that we were not covering yet, right? Because we zoom out from this like complex research on RPC clients and servers, and trying to identify the RPC methods that we could start documenting. If we zoom out, we pretty much start looking at the handle itself, and the handle is the one that will survive the change of the protocol, for example, right? Because remember, the research goal is interacting with SIEM to do anything with services, specifically creation and execution. So the SIEM handle would survive. Now, I haven't tested something yet, but so I heard that you can do a duplicate handle, a process dupe, and apparently that does not trigger the the access control request verification. And that was done by also James Forshaw with local processes, for example.
Yep.
So in local processes, if you do process dupe of the handle itself, it will not trigger that verification of the access. But I haven't tested it kind of over the network, so that would be something to kind of do more research. But you see, you are pushing the person executing this to think about something else. And something that you also told me once, Matt, is that your detection is as better as your previous one, right? That's what you said, or how do you phrase it?
Yeah, well, I don't remember exactly what I said, but I think what you're getting at is, again, not letting perfect be the enemy of good.
Yep.
And that we're only, like, the best successes that we can have as detection engineers is to have gradual improvements. And by improvements, I mean, like, increased robustness, right? Like, had you not come to the conclusion that obtaining a handle to the service control manager was, as I like to refer to, a potential choke point, right? Where, at least to date, presumably, until like someone like Forshaw came about to identify this, that all service creation and modification likely had to channel through that potential data source. In this case, what was it, 4697? Yeah, the ones based on object access. I mean, the
handle, that was 4656.
Yep. Yeah. So that right there, like, without having prior knowledge of that, we could probably have a really good picture of coverage, but because we didn't have the required knowledge and vocabulary to ask the right questions to identify that handle as that choke point, our coverage was only so good at the time.
Yes.
But by going that extra step that you did, identifying that common point that it seems an attacker must go through, we've just arbitrarily increased our coverage thereafter.
Correct. Exactly.
And this is like pretty much the same process that an attack researcher like James Forshaw is going to be going through, right? Identification of those choke points, identification of the technical controls that are logged potentially at every point in the way, and identifying ways to subvert them, or in our case as detection engineers, exploit them fully to turn them on and contextualize them. Yeah.
Yep.
So that's great. Yep.
Exactly. And that to me, it's so important because we just went a little bit more. I would say we went beyond what we have seen so far, like with a lot of other detections, right? Because we all are sharing our research, which is great, right? But then we started seeing, what, there was something else that we could do, and that always also proved the point that whatever I share, for example, in the community, there is more than you can do with it, right? There is a lot of other things that you can do. So do not just think that because something is just shared, that's just the end all, and then there is nothing else to do on the top of that research. And I think that that's pretty much where I believe there is a lot of opportunities for others just joining the community, or people that are just starting in this career. This type of detection, by focusing on 4697, for example, for creation of services, or only on the registry, that has been shared for, I would say, like a couple of years already, right? But I haven't heard too much into monitoring the handles on the SIEM. And you can just set it. For example, we're just gonna go real quick because we don't have much time right now. But
now, Roberto, technically we have as much time as you're willing to give. I've got like an extra hour.
Wow.
You can take as much time as you want. So
Great.
anyone who wants to stick around, this is all being recorded anyway, so we're good.
Nice. Okay, well, so then we can do a quick test, and hopefully this one works. Okay, so yeah, so I'm going to show you then how you can start enabling this or adding the access control entry to the SACL of the SIEM of the SC manager service. And I'm going to explain to you what that actually does. So let's just go directly to some coding here. So let's just move to the next one. I'm going to share this scripts later. So in order to do this, actually using the SC utility and using SD show in order to get the specific the security descriptor of the SC manager service itself, because I want to start auditing access attempts on that specific service. Now you can also apply the let's call it the audit rule. You can apply it also on the service itself, on a very specific service. Like, for example, I remember Dwight Johnson, yes. So he worked also on some research with us when I was doing consulting with him, and he was querying on a specific service because he identified that the service was vulnerable. That was vulnerable to DLL hijacking, and then after that, there was a patch, so the service was not vulnerable anymore. But meanwhile, there is no patch, right? You can start creating audit rules on those services that are vulnerable to specific things like DLL hijacking, right? But something that was very interesting in here is that, for example, and this is just kind of like telling a story, because I think that that's also how we learn, just by sharing a few things that I found very interesting. For example, I was monitoring for anybody querying the specific service that Dwight mentioned in his research that was vulnerable. And I wanted to monitor only the queries to that service. I just wanted to monitor him trying to check the service if he was running or not. And I wanted to catch him before he even do anything else. But then the API that he was using in order to do that, or the RPC method that he was using, it was not querying the service directly. It was actually querying the SIEM and saying, give me everything. And then he will parse that result, and then he gets information about one specific service. So that was very interesting to me, because now he is making me move my audit rule to the SIEM, to the SE manager. So that's the type of research that I love, because it just gives you some of those opportunities to identify where it would be the most strategic way to create an audit rule when you talk about SACLs and access control and all those things. So that was very interesting, and I found out because the tool that in his blog post he used se.exe, but the tool that he developed to do that was a total different tool, and that other tool was not querying the service directly. So something just to learn about that interaction. Yeah. Anyway, so we're going to do this. So let's just first enable our audit polls, but those need to be ran on the target, because we're creating the audit rule on the SE manager of the remote computer. Because remember, the SE manager, the RPC server, is going to be hosted on the remote computer, because we're doing this remotely. As Matt said, the RPC server also can exist locally, right? But in this case, it's going to be on the target computer. So let's just enter a PS session. I'm going to run this command real quick. And I don't know why it's not liking this. Hold on. Huh. You know what's weird? So let me just delete this. When I move to the this one right here, which is technically the same, that one works. Yep. It's not the same.
That blows my mind. I don't understand that.
I don't know what that happens, but I noticed that, because when I did the tab completion, like if I go here and I do enter, yeah, you see PS session and then computer and so that works, but somehow on the line over there on the top, it just somehow doesn't work. So that's just so weird. Okay, so let's just run this. That once again is being executed on workstation 6, and that's just enabling my audit policy handle manipulation, which by the way, it's not. So this is something also that you learn just by doing these interactions, and once again, just testing like trial and error and all the stuff. Those are the two policies that you need in order to enable the audit on the services, for example. If you enable only handle manipulation and you don't do this one, it's not going to show you anything, and vice versa. So those two need to be enabled. So that's something also that you learn just once again, just by testing and testing and testing, because that's not documented at the moment. All right, so those two are great. And then what I could do is I could just directly get the security descriptor of the SE manager. Yep. And then just run that again. And as you can see, like it just gives me this whole string, and that string is in SDDL format, which is the security descriptor definition language format, SDDL. Yeah, so that could be actually translated. So you could just run this convert from SDDL string, and that should give you all the, for example, names of the access rights that are being defined in the DACL, the discretionary access control, and the SACL, system ACL. So I could see that there is some auditing actually going on the SE manager, but this auditing, let me just point it real quick, it's only for failed access, for example. So that's very interesting, because now I know that anything that fails to get a handle on that is going to trigger something. So then I started thinking about this. I was like, all right, so when would that be a situation where there might be a failure of the SIEM handle that I might be aware of? And I started thinking about it. And I remember that there was a technique that was used in PowerShell Empire that you try to get a handle of the SIEM on every single endpoint. And the ones that succeed, that means that you have admin access to that computer. The script, I believe, is called find local admin, I think it is. So that script is going to use the SIEM, try to get a handle. Once it gets it, great. If it doesn't get it, it knows that it's not going to be an admin on that computer. So that will generate events, because now we know that the SE manager service is going to audit every failed access, right? So that's pretty cool, because at least we have a data point that we can use for our next research. Like, that's something that I would just put on my notes and just wait until I talk about that other thing. So that's, once again, how you start identifying other data points that you could use for other pieces of research. Anyway, so that's great. So now what I could do is add in what's called an access control entry to the SACL. So in other words, this is the system access control list, which is translated to all the way from here. Yep. Every time you see the capital S with the two dots and then the two parentheses, open and close, that's going to be an access entry. Every open and close is going to be one entry in the SACL. So we just want to add another entry, and in order to do that, we can actually run this. Yep. So let's see, SDDL. Yeah, that should work. And so that pretty much is going to give us. Let me just run this. That's going to give us the new security descriptor that is going to have the last entry here at the bottom. This is something that was not part of the initial security descriptor. So I just appended that to the old one. And then in order to make things easier, I just translated this thing for you. So pretty much AU means audit. That means that this access control entry is of an audit type. And then SA means it's going to monitor for successful, and FA means failure, okay? And then all these access rights, these are called ACE rights, so access control entry rights, are going to be translated in here. So you could see I'm going to monitor for anybody starting, stopping, pausing, querying, configs, whatever. And this is going to be, once again, just access requests, because the SACL is going to monitor for the request itself. Okay, so that's something that I want to monitor in my SIEM. So anybody who accesses with those type of rights, then I would like to know. And then at the end we have this. This is NU actually here. NU, as you can see here, NU also. NU means the network SID, the security identifier of the group network. That is, as you can see here, network logon users. This is a group identifier added to the token of a process when it was logged across a network. Okay, so logon 32, yep, there it is. It's corresponding to the security network grid. So that means that this will only trigger when there is actually a network context to the interaction with this service. So
That's pretty convenient.
yeah. So in other words, if somebody just does services creation locally, then it's not going to trigger. So that way you start, limiting also the amount of data that gets created. Once again, we had an engagement right before, like a year or two ago, and there was a lot of services being created, but all of them were local. So having that additional context of the network context for this type of access requests, it just takes all the local ones away, and then you focus only on the network ones, and that's what we want, right? That's the network context that we need. And this is, of course, besides not going deeper into ETW, because I'm pretty sure there is something in ETW that will give us also additional context, right? But something practical that I could use, it could just be as simple as an audit rule on the SE manager. All right, so then I can just set this up. So I'm going to use SD set, SE manager, and the new SDDL, or the new security descriptor in its SDDL format. That's pretty much what it is. As you can see, that's successful. That's good. And then I can just exit out of this. Okay, so now let me go to my events, just making sure that I'm going to clear this up. And I'm already, so this is, by the way, this is computer workstation 6. That's the one remotely. And, and by the way, this is a computer that I built through ARM templates in Azure. And all these templates are in the project Simuland. It's also part of OTR, the whole community. So every time you deploy it, you get the OTR banners and all the stuff. It took me a couple of weeks to figure it out, believe me. I'm always like try to be a little perfectionist and making sure that the image look good and all the stuff. So people that know me will know that this didn't take a few hours. So
That's why I'm laughing so hard right now.
Okay, so as you can see, I can see this 4656, which, by the way, are the events that I'm going to monitor, that there was a handle requested to an object. And as you can see, this is not only services, right? This could be different type of objects, like registries as well. Object type key, that means that that's a registry. So then I believe that I could just attempt to do, let's see, I don't know if I try this. Did I try this? Maybe, hold on. So let's just try this, get service, no. Get service, computer name. Oh, cannot find the service. Oh, okay, sorry. Get service. Let's see if it does it. Sysmon and computer name. There it is. And then we can see a specific event in here, 4656. And this was just created right now. And you can see that services.exe is handling that request. And this is, once again, even though I query for Sysmon, it captured the connection at the SIEM level. So it didn't go all the way to Sysmon. If I create a SACL on Sysmon, then it's going to generate a specific event for Sysmon. But once again, I want to track everything that goes through the SIEM because my research goal is focused on the SIEM. But this is the context that we get, for example, from Sysmon, right? Because Sysmon would tell us somebody created a registry and it's apparently it's a service because it's part of the service database path. Oh, but I'm sorry, it's done by the services process. So who knows? It might be local or network. So you get a similar context with this, right? Because at the same time, I could say, yes, this is a service, the SE manager being accessed or requested to be accessed, and the services.exe is handling that. But then I get this, which is additional context to this event, something that I do not get from Sysmon, right? This is the the user context attached to this. Now, what I can do now is clear this, my filters. And before, what is my event? 1 second. That one over there. Okay. So I want to look for this loan ID. And then I'm going to filter for my latest 4624s. And I have one. And if I look for, yep. So as you can see, my 4656 event has the login ID of P. Gustavo. And then at the bottom, you can see that this is, of course, done over the network. If source port has the number 0, that means interacting without looking at anything else. That just means interactive. But then of course we get context about the logon process being used. But so that tells me, and this is logon type 3, that tells me that this access to the SIEM was done with a network context, for example. So that's also, once again, great information to join, and that way I could then tell somebody, hey, somebody's interacting with the SIEM and is doing it over the network. Now you might tell me, but how do you know what they did or something like that? Well, there is a connection to a service controller, so they're connecting to it. And if I'm not mistaken, so if I just go back to my 4656, for example, and I look for P. Gustavo, since it's the one that did the thing. Yeah, second. Let's just go back in here. Yep, that one. And let me see if another one in here. That one. Connections, and just another one here. I'm just trying to see these other ones because there were a lot of them, as you can see. So that could just give me some context around what it is that was happening in there. Let me see also here if there is anything else. Oh yeah, so then after that you can just set it back to what it was, just by using the previous security descriptor, and that will give you your SIEM to what it was before. So just in case if you want to test this at home. But
Hey, Roberto.
yes.
My memory may be a little fuzzy, but in the PCAP, if RPC is being used, do you get the process ID of the client that initiated the connection? Do you recall if that's the case?
In the PCAP?
Yeah.
Not that I'm aware of.
Okay.
No, but
Gotcha. All right.
yeah, I haven't seen that. I mean, there maybe is because I haven't. Yeah, because I was going through the specific calls and I didn't see that particular information. But
Okay.
something that we could do is just looking back at the model. Is the communication between, for example, of course, there is a network, a Sysmon event ID 3 being created, and then you have also a services event ID 3 being created. So at least from the source and destination port, that could be one way to map the target and the client. But
assuming both are monitored, of course.
Yeah. Exactly. Yeah. Which it's something that it might not be always right, but it's just one way. But those are the things that I start identifying, like that might not be a good detection to build in a big environment either, because this might be changing a lot, and so I don't know how. So that's something that probably it would be good to add more context to it and see if that makes sense to do it that way. But at least I know that the source port from the client and the source port from the target, they're going to be the same if the communication happen. So services is going to be the one doing the inbound, outbound connections. And then of course on the client, there's going to be any process doing this type of activity. Okay, so there's a couple of things that we could try. So pretty much like this, let's just go over real quick through those because we don't have much time after that. And the WMI, actually, I have that script. Let me just see if I have the thing. I don't know if we had that one as well, Matt, the WMI one. You said that you had one that was better, right? Because it was directly through PowerShell.
Oh, I didn't say better. I said I maybe had one. I'll try to hunt that down again. If we can't find it, I mean, I feel like we've already inundated everyone with awesome information anyway.
No, yeah, because anyways, I can't even copy and paste. I was thinking on copy that and then just going through the commands, but I cannot even copy and paste. But in reality, what's going to happen in here is if you use SC, for example, that's going to be RPC over TCP. We can maybe test it. So workstation 6, I think that I could do query, Sysmon, I think. Yep, okay. So if I just stop this again, making sure that I get a fresh one, So if I just run that again, and you can see that this is pure RPC directly over TCP. I don't see any name pipes being used. And as you can see, it's going to use the open service, query service status, and all that. So this first one is the open SE manager. It's just that it's not the regular open SE manager W. I believe this is the A. So this is this is open SE manager 2, I believe. So we can look for it with the opnum with the specific procedure 64. You can just look that up, and that's going to be related to the open SE manager, which is the one that gets you the handle in order to perform other operations. So as you can see, like
you could reference those.
Yes.
Some of those are documented in MSDN, right? But
yes.
aren't okay. But in most cases, when dealing with like this nitty-gritty RPC stuff, that may not be the case, in which case anti-object manager can help you associate an opnum to the actual function.
Yes.
Right?
Yes. So for example, at least because at least we were able to get the server in here, so that should be easy.
Yeah.
So we just get that SIEM server, and then we can just, I believe, select, and then we extend the procedures. Yep. So and then we can select the name, and that should give us. And let me just do this again. What is the opnum? Procnum. So we do name and then procnum. And that should give us 64 is open SE manager 2. Yeah. So
procnum is opnum. Yep.
Opnum, yes.
Yep.
Which is the function or the procedure that is being provided through the RPC server service. So this is why we find them on the RPC server.
Cool.
Yep. Okay. So then, as you can see, that first one is just gonna do plain, plain RPC over TCP. And so I assume that it's just be Gustavo again, I guess. Control SA, and that just happened to 2144. Yep. So that's a different logon ID. So that's pretty much, once again. Let me just see the other one real quick. Yep. And then the other one. Yep. So you start getting a lot of information about that network connection. So that's pretty cool because in this one, for example, like if I look for the 5145s, there's not going to be none. So as you can see, like through the RPC, once again, we validate our assumption that it's not going to be using the name pipe based on documentation. So 5145 is not going to show up. So that's just, once again, just additional context that you get with this type of activity. So if we run the other one, which I believe I don't have that, I should have that in there. Let me see if I can copy and paste it real quick. The sharp SE thing real quick. If not, you guys get the point because we've been using RPC. So anyways, but also when I was testing WMI, so something that we could do, of course, even in a tweet later just to share that output, that one is still going to be touching. We can actually test it real quick.
Wouldn't it be using its own WMI specific server and client components?
Yes.
Okay.
It would, exactly. So we can see it over here right now. So I think I can do this. Workstation 6 service. There is service query, I think it is. 1 second. I think it's service query. There it is.
Service list.
List.
To just enumerate?
Yeah. Yes. So if I do list, right? And let me just turn this off. Yep. There you go. It's going to be using its own. This is going to be through DCOM. DCOM RPC. So we don't see any, direct, RPC methods being used. This is going to use the Win32_service class, I assume, when this occurs. So then if I just look at my events, of course, no name pipes, 6, but we get, there you go. So I didn't know. Yeah, there you go. So pretty much what this did, it just started accessing. So when you do the list, it's going to go through every single service, apparently. and I have a SACL modify on the service that Dui worked on, which is IKEEXT. So as you can see, the WMI way still used a handle to do this to the SIEM. That's what we see, like session emp. Dui identify two services, session emp and also the IKEEXT. And then of course it's going to get a handle to the SIEM. As you can see, the service active is the database. So that means that even when we use WMI, and we didn't use RPC over SMB, RPC over TCP, we just use DCOM, and DCOM RPC. The handle was still there. So that's something that definitely will be interesting, right? To kind of like cover, as that's something that might be very interesting to start monitoring in our next probably iteration of detections or so. This was great because once again, the WMI execution was not part of the SIEM documentation, because all it said was must be done through RPC over SMB or RPC over TCP. So that's pretty cool because we identify something that was out of the scope from a documentation perspective, but it seems that it actually did it, just by direct DCOM as well. So that's interesting. I would like to know, for example, the 4624s as well. Just making sure that, there you go. No, that one. It just generates so many things that, yeah, we have P. Gustavo here. Yep, with this logon ID, logon type 3 over the network. Yep, there it is. And that's pretty much the next event that is going to be generated, authentication, and then get the handle. Yep, so those two will be great context to add. So even though we didn't have a direct service process creation, we know that it's going to leverage the same type of activity. Of course, it might change a little bit, I assume, if it creates the service in this area. But once again, we lose the context of network context for this. Anyways, but that's pretty much it. Then I share a few detections, just doing a couple joins. This is Jupyter notebook using a couple of queries. Nothing crazy. Like if you go through the queries, this is just joining event ID 4624, 4697, 5145, all of them on the logon ID, and then I could get some information about it. This is just services being created, looking at the registry by itself. But then of course we're just missing the 4656 with the 4624, which is going to be a similar query because it's being joined on the logon ID fields. So once again, something that we can add to our detection report at the end and identify that there is additional resources that that we could use. And this is once again at the end, just as how you said it, Matt, at one point. This is what happens behind a Mordor dataset. So this is the type of work that it just happens a couple nights, and then I just decide to pack it and then just share it with our community. And then then I hope that that community can then use it and start learning about this. Because for example, one of the goals of this project is also provide data to those that are not too comfortable doing all this process, like modifying your own SIEM. You might be afraid, like you might be working on a computer that is not a VM, things like that, right? So you might be a little afraid of running some of these commands. Then just get the data. And once again, also, I do not like to limit the data set, which means that this is what I could have done. I could have just given you a data set that was covering that only and tell you, hey, I ran everything, I just enabled everything, filtered everything to the events that I believe belong to the detection that I want to validate, and that's it. And then I call it a day and I'm done, right? No, I give you more so that way you start getting familiarized with the field names, with the values, what it is that you're going to use in a query if you deploy this, of course, in production. And that's pretty much it, I would say, from this presentation. I had just one thing that I wanted to share, that it was related to something new that I added to Mordor. But if we don't have time, It's very simple, but we don't have time. We can just leave it for a tweet or something like
By
that.
all means, my friend.
Yeah.
Go
Oh,
for it.
you good? This is good, man. This is a good webinar. We should just take the time that we want to.
Let's take all day. I could use a break from global supply chain compromises.
Oh yes, same here, man. Same here. I just being crazy about that. Okay, so I'm gonna show you this real quick. Let's see if I can just share my. Yeah, I can just share this thing real quick here, and I'm going to make it bigger so that way you guys can see it. There you go. And take this. We don't like any of this writing here. Anyway, so in the Mordor project now, there is a script section, and I organized all this because it was terrible. And there is one section that says transformers, and there is one script called Mordor Transform. And I'm just gonna explain what this is real quick. So let me just first unzip this. Let me just go there. So if I go to scripts and I go to transformers, okay, and then I'm going to unzip this data sample. Okay, so now I have a JSON file. So pretty much that's what you will get from a Mordor perspective, right? You will get this JSON file with all these lines, records of JSON, a JSON record. So the reason also why I choose JSON, because it's practical and easy just to plug anywhere else. I could have given also an AVTX, but I like to just grab it, grab the data, send it to you, put it into a Python script, and then you use it, right? So you don't have to worry about like parsing the XML or trying to figure out different ways how that could be ingested somewhere else that that accepts EVTX. I just want to give you JSON, and that's pretty much what I provide to Mordor. Anyways, but as you can see in this JSON file, you can see that there is specific field names like this, like host name Mordor DC char local. So if I want to share this with somebody else, and they might want to use this in their organization, all they can do is they just grab this data and push it to a lab environment, and that's it, right? Because it has values that do not belong to a specific organization, which makes sense, right? So I was thinking, how can I update these values and make it look as if this data set was created in a different environment? That was number one. Number two, the timestamps of the Mordor datasets, of course, are going to be related to when the time that I created. So what happened with this? Well, there is a problem. If I create a dataset in 2018, then you have to query all the way back to 2018 or trying to figure out the specific time where it actually happened. And it's not as convenient, especially if, for example, like if we figure out how to change these values to some values that will map to an organization, that event will still be in 2018, and that will not be part of your current queries, like doing some of your validations. So what I did is I created this script that what it does, it ingests a Mordor dataset, and then you can give it a time, and then it's going to change all the timestamps to that specific time context. So it just grabs the minimum, gets the difference, and then adds that delta to every single timestamp. So the data set is going to look as if it happened in a specific event, a specific timestamp or time frame. And since we're doing the delta additions to all the timestamps, then it's going to look like as a regular behavior. Because if you just change the timestamp to all of them, then you're going to have a big thing going up in your events, and it's not going to be that cool to work with. The second thing is that you can add a parameter which allows you to, and by the way, it's just supposed to be M in there. And then it's going to point to a YAML file. And then that YAML file is pretty much a translation. So Mordor dataset is also, the Mordor project, it's also a project that documents its own environments. And it's done through the project Simuland, because that's the one that I use to share templates to create all these environments. And Simuland has a specific configuration that every single Mordor dataset most of the time will have. So I know that we have all these computers, this domain controller. On the left is going to be the current value, and on the right is going to be the new value. So this script uses pandas libraries, which allows you to do a replace to the whole data frame, to the whole data set, and then allows you to just to do this in very quickly. So as you can see, I could take this YAML and I could change everything, the domain, like the domain name, the full qualified domain name, some usernames, for example. I want to test this data set to look like it came from our, I don't know, CISO, who knows, or our, what's it called, C-level, right, people. And then you can, set the IPs that you want. And of course, I have them, documented. So this IP is the domain controller, this is the WEC and all the stuff. So then at the end, I can just run that. So let's just run that real quick. So Python 3, Mordor Transform. I'm pointing to the current data sample. And then I'm gonna make it look like, so as you can see also, every single Mordor dataset has a timestamp attached to the name. So at least you know that this was from October 9. So I want to make it look like if it was 2020 December, what's today, 18, and then that happened today, which would be 14, let's say 10/00. So let's just do, yeah.
So that would be like the base time that you're defining, right?
Exactly.
Okay, yeah, cool.
Exactly. So as you can see, like this, went really fast, like in 2 seconds. And then I got this new data set. And as you can see, even the name itself, it's already the timestamp where you want the event to start. And if I go to this, it's going to look the same. But now if I look for timestamps, which would be, let me look for this real quick. Just Control F. There we go. Timestamp. There it is. So as you can see now, the timestamps are related to December 18th now. And some of them will start on 2 p.m., right? So as you can see now this data set, if I just send that to somebody else, it's going to look like it happened, today, like a couple minutes ago. So you're going to start doing this type of things. And now if I'm going to do this again. So let me just, and by the way, the ASCII also, I was looking for the right ASCII, by the way, so it also took me a few hours. So let's see. So now I can give it another time. So I'm going to make this to be the future. And I'm going to set -m, and I'm going to point it to my mappings. Okay. And that's just going to go through the whole thing. It's going to take every single value that is in the dictionary, in the YAML, and then it's going to start updating this data set. You can see it took 10 seconds, and it's doing it very fast because this data set is a little heavy. And it created another one for the future, the December 20. And if I look for, let's look for Mordor DC, it doesn't exist, right? But if I look for, let's see what the mappings were, demo DC, right? And I go to my future data set. There it is. So this changed all the computers where there was Mordor DC, change it to Mordor DC. Also, I give it the full qualified domain name, and then I give it also the domain name. So it changed every single thing that is related to my Mordor environment. So you can call this a Red Canary, Microsoft, anything. So the data set itself is going to look like it happened on an environment. So then you can take this and you can inject it into your pipeline, and it would arrive and look like as if somebody executed that technique in your environment. That's pretty much what this is about. So this is called Mordor Transform, and I finished it last night. and it's something that now everybody could use. And as you can see, the process is very easy, just to change the timestamp and then create your YAML file, and your data set could look like it happened in your own house. So that's pretty much what this feature is about.
That is freaking awesome. Great work.
Thank you very much, man. And I think that was it. I didn't have anything else besides that. I have a lot of things in my head, so I think that I cover most of them. So yeah, but that's pretty much it. I don't know if anybody had any questions in the past hour and 40 minutes that we've been talking.
I just saw one question post. Would it be possible to ingest Mordor datasets into Splunk? How would you go about handling that?
Yes. So as far as I know, I thought that their what's it called? Their agent, like Splunk agent, had a JSON input, as far as I know.
Sure.
The other thing that you can do, for example, is I know that you can collect data from Kafka brokers to Splunk, because there is a plugin for that. So what you can do is just stand up a container, like a Kafka container, which is very easy to do because if it's a Docker container, it's just like one command away. And then you can just pour that data to that Kafka broker, and then it will be available to a lot of other applications. So it could be Splunk, it could be like, like other SIEMs out there. So that would be one of my ways that I would do it, because loading into a Kafka broker would give you access to other applications that are compatible, because Kafka is a tool that is used commercially. A lot of people use it, a lot of companies. So they definitely have a lot of plugins to do that type of thing. So I believe you can do that, as far as I know, Splunk to Kafka, if the Splunk client does not have a JSON input, because I don't work with Splunk, to be honest. So I figured out how to do it with Azure Sentinel, with also an Elk Stack, which is very easy. So those are the ones, but I'm pretty sure it's possible. It's just JSON, so it's easier to ingest, as far as I know. So,
Awesome. Yeah. Cool. Well, thank you so much for your time. I don't know about everyone else who's listening, but every time I get the chance to chat with you and just hear you talk about your research, you always like breathe new light and like hope into me, and excitement about how sexy it is to be a blue teamer and just defender in general. I mean, like a lot, like many of the concepts that you're talking about, like can be easily translated from attack research into detection engineering. So like identification of those choke points, for example, like you recognizing getting the handle to the service control manager, at least like we would assume, and we can now validate that most legitimate service related activity is going to have that attribute, which can be audited, which can be further contextualized and tied to other events. And so whether you're the threat researcher trying to identify new valuable resources that you explained today, that's super valuable, or the data scientist trying to make sense of everything and contextualize everything and extract value from this. To me now, like I now see much more clearly the value that can be derived from Mordor datasets, especially now knowing all of the research and the just hard work that goes into generating those. So thank you for all the work you do. And I'm just so grateful to have you as a friend, and for all of your transparency and just being such a positive force in the industry.
Thank you, man. Thank you. Really appreciate that. And I hope that, definitely there is also, the, what's it called? The perception of doing this as well. As you can see, it's just by doing these trials and errors, are just asking questions, failing right away to just trying to see what actually worked or what didn't. And I think that that's what's also the beauty of this process of threat research methodology. And I hope that the community at least got something something out of this, right? Because once again, there is a lot of methodologies being shared out there. And I just figured today, I could share a little bit of the things that that I also do, kind of additionally to what I pretty much have seen a lot of people doing. But so I also want to thank you, Matt, because of all the help as well. And once again, not just professionally, right? Because we don't always talk about research. And definitely I missed our cup of coffees. So hopefully when this pandemic is done, we can talk about not too much technical stuff, but actually just life in general, which at the end also fulfills me a lot. Every time I talk to you and it's not technical, it actually makes me feel great after those conversations. So it's amazing because So thank you very much for everything. And I also want to thank the Red Canary family, and for giving me the opportunity to be here and just share all these things. To be the last episode of December, of the year 2020, which was a crazy year. But and also want to thank my team, the Mystic team, which are also amazing, just also giving me access to all these things and giving me the opportunity to spend time just talking about the methodology and talking to others in the community. That's what I just also love about my job. So, very blessed to, to be doing all this, with you and, Red Canary and everybody else. So thank you very much.
Absolutely. Man. Thank you, man.
All right.
Yeah. And to all the attendees, thank you so much for your time as well. We know your time is really valuable. And yeah, we hope everyone has a wonderful holiday time. Happy New Year, and can at least spend a little bit of time decompressing, hopefully in between global supply chain compromises and pandemics.
Oh man,
I'm laughing and I'm crying at the same time.
I'm actually taking a break on Saturday, so I'm gonna get a massage. So I'm gonna be just relax and just forgetting about a lot of things, because definitely need it. It's been a crazy couple of weeks and crazy couple of months too. So
yeah, for sure.
Yep.
Well, enjoy, man.
All right. Thank you, man. And thank you everybody
thank
else.
You.
And I'll see you guys next year.
All right. Happy New Year.
Happy New Year, man.